The graphs below show the boiling points of straight chain primary alcohols and the straight chain of ketones with different number of carbon atoms. We are given a graph of boiling point versus the number of carbon atoms. 3.1.1. Define the term boiling point. This is the temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. 3.1.2. Explain why the boiling points of alcohols increase as the number of carbon atoms increases by referring to the type and strength of the intermolecular forces. As the number of carbon atoms increases by referring to the type and strength of the intermolecular forces. Okay. An increase in chain length increases the strength of the intermolecular forces. And in this instance, the type of intermolecular forces that we are talking about, it is the van der Waals forces. Or you can say the London dispersion forces. 3.1.3. Explain why the curve of the alcohols is higher than that of the ketones. Refer to the type and strength of intermolecular forces involved. Well, first of all, alcohols have hydrogen bonding. Compared to ketones which have the dipole forces. And of course, they both have the weak van der Waals. Okay. And then now we need to refer to the strength. H bonding have a greater, or we can say H bonding is stronger than the dipole. They say that we should refer to the type and strength only. Okay. The vapor pressure of the alcohol is compared to that of a ketone at the same temperature. 3.1.4. Why must the alcohol and ketone which are used for the comparison have the same number of carbon atoms? Well, it is so that we have only one independent variable. Okay, this is what I mean. Let's just say we have an alcohol with 2 carbon atoms, like that. And then we have a ketone with 4 carbon atoms. Although we know that the strength of the hydrogen bonding, it is stronger than that of the dipole. There's another factor here that we need to look at. The number of carbon atoms is not the same. So it means that we have 2 independent variables. We will not be able to tell exactly what causes the difference in the boiling point, because for the first one we have 2 carbon atoms, for the second one we have 4 carbon atoms. So it could be the chain length, or it could be the type of intermolecular forces that are involved. So to make the experiment fair, we need to have the same chain length and then just change one thing. Okay, so that we have only one independent variable. Three point 1.5. Which one will have a higher vapor pressure, the alcohol or the ketone? The one with the lowest boiling point will have the highest vapor pressure. So in this instance, it is the ketone. It has the lowest boiling point, 3.2. The boiling points of propanoic acid and propan 1-ol are compared. 3.2.1. Which compound has the higher boiling point? It is the carboxylic acids, of course. So it is the propanoic acid. And then 3.2.2. Explain the answer in question 3.21 by referring to the type, strength of intermolecular forces and the energy. Well, or we can just say carboxylic acids have hydrogen bonding plus the weak van der Waal forces, and then alcohols have hydrogen bonding as well, plus the weak van der Waals forces. However, carboxylic acids have 2 sites for hydrogen bonding, while alcohols only have 1. There is an increase in strength of the intermolecular forces with an increase in the number of hydrogen bonding sites. This means that the carboxylic acids will require more energy to separate the molecules compared to the alcohols.